Hi, Macy.
Let's see if that makes her happy. That was a good one.
That was a good joke.
All right. So this page is all we have, and then I know yesterday, after 3.6a, y'all did 2, 7, and 8. Today, do the remaining and turn them in. All right. So Max, let's read the instruction. The graph.
The graph of f prime is sketched below, and its domain is the set of all real numbers. Use the graph to answer the following questions. Justify all of your answers in terms of f prime.
So our key things, the graph is f prime. Typically, when I give you a graph, it is the function, but today I'm giving you the slope graph to begin with. And yesterday when we justified it, we said f prime because, f double prime because. Today, everything is going to be because of f prime. So we're not even looking at f double prime on our card at all right? So looking at part A, it says what interval is the original graph, df of x decreasing? Let's underline that piece. And again, we are not looking at double prime at all. So if the original graph is going down, what do I know about f prime?
It's negative.
It is negative. So let's go ahead and notate all the positive and negative. This is above, this is below, here's above, below, and above. So anything that is negative is going to be our decreasing function. So I'm going to take out a highlighter, and wherever it is negative on my f prime, I'm going to highlight that piece with one color. So how many intervals are we looking at the original graph that is decreasing? 2. So we have the first interval is at -2 to 0. Union, what's the other interval? 2 to 3. In our reasoning, it says to justify by just f prime. So because f prime is what kind of sign? Negative. And then let's go on to the next piece. It says what interval is our original function increasing? So going back to my card, we're only looking at f prime. It's folding away. It is increasing when it is what kind of sign? Positive. So I'm going to use my different color and highlight anywhere I see a positive. And the graph goes on forever. There's no restriction on the domain, so I should have mentioned that at the beginning. So how many intervals are we looking at it for this problem? 3 of them. So we have, the first one is -infinity to what number? -2. Union what to what? 0 to. Union, and our last one? 3 to infinity. Y'all keep arguing, I'm recording. Because f prime is what kind of sign? It is positive. Now let's look at the concavity. Part C. Kenzie, read part C for me, please. So it is concave down. So if it is concave down, going back to our card, the graph is concave down when f prime is doing what? It is decreasing. So anywhere my graph is physically decreasing, from left to right. So I know this piece is decreasing. Stops right here. Do I have another spot that's decreasing? Right here. Any more do I have? The rest are increasing. So let's put on here. We know we have 2 locations. -infinity to what number is my first decreasing stop? -1, union. And then the next one, we want to approximate after the 1. What number should we put between 2 to 3? 2.5. Now, if the graph is not so clean and you tell me 2.49, that's okay. And our because, again, has to state f prime is decreasing. So when you guys are defending this, decreasing versus negative is 2 different things, okay? So don't interchange them. All right, part D, Hamilton, let's read.
What values of x is f of x that are relative to x?
All right, so we have relative maximum. I think I'm going to highlight this as well since I did color coordinate. That's so pretty. All right, so relative maximum. So looking at my graph or function, would you agree that's a relative maximum? And that is because f prime is changing from positive to negative. So on our graph, let's see where it is going from positive to negative. Positive to negative, it is that point. Where else are we going from positive to negative? At 2. So let's put on here what values of x, and we're looking at 2 locations. And I want to use my set notation from 2, and then the other one is positive 2 and negative 2. And that is because, and again, our reasoning has to say f prime. The sign is changing from what to what? Positive to negative. Do not say negative to positive. That's going to be the relative minimum. So let's mimic that on E. What values of x is there a relative minimum? If maximum is from positive to negative, minimum must be from what to what? Negative to positive. Do I see one right there? Is there another spot? Yep. So we have x is equal to, with my set notation from, the first one is at 0, second one is at 3. And what is our reasoning order? Because what? F prime? Good, negative to positive. All right. Okay, last part before we graph. Lily, read the part F.
What values of x and f of x have a point of inflection?
So our point of inflection is where the concavity changes. So here I have my point of inflection. That means f prime is increasing to decreasing or decreasing to increasing. Okay? So we have increasing to decreasing, looking at the first one. This one is decreasing to increasing. So we know concavity is going to happen right here. Here we have increasing to decreasing. Concavity right here. Do you have another spot down here that I approximated? So we have our x is equal to, what is my first x value? Negative 1. Second one? 1. Third? 2.5 or 2.5, okay? Because f prime has what? Slope of 0, that's good. What else is it called when it's increasing to decreasing? What is this high point called? Relative maximum, or if I go like this, we have relative minimum. What do we call that together? Extrema. So has relative extrema. So I heard someone say the slope is 0. Yes, that is also correct. Some people might also say it is going from decreasing to increasing or increasing to decreasing. That is also correct because in the end you're defining this. All right. So then let's go on to our last piece. Josiah, last one. Go read.
Given that the graph of f of x contains the point negative 3, 1, sketch a possible graph of f of x.
All right. So we are actually graphing f of x, and we're going to graph that from the known information about f prime of x. And on my f prime of x, let's make our line just like the x coordinate of the domain above. And I want to graph when f of x or f prime of x is equal to 0. So at all the locations of 0, let's go to them. It is 0 at negative 2, at 0, 2, and 3. So what I want to do is go down to that and put a line to it. So I'm not graphing too much all at once. So let's put on here. These values are 0. You can write m is equal to 0. That's still correct. All right. And then let's see what the signs are of at those points. So from the left of negative 2 is positive. Between negative 2 to 0 is negative, positive, negative, positive. So let's put those signs on the bottom. Negative and positive. And then I'm going to change my color because I want to look at the behavior of the original f of x. When f prime is positive, the original is going up. It is increasing, decreasing, increasing, down, and above. And there's one point that we have to actually go through. At negative 3, 1, put a big fat dot. So how high above you get, how low above you get, does not matter. So if you want to look at my graph first, so you know where I'm turning, will be very nice. Is everyone ready? So when f prime is 0, we're going to turn, turn, and turn. So, but then we have to start by increasing. So I'm going to remember where I need to go ahead and turn at -2. So I need to turn at -2. And I need to go ahead and turn at 0. So I need to keep going down until I get to 0, turn. And then I need to turn at x equals 2. So go up and 2. How high or low you get doesn't matter. And then when I get to 3, I'm going to turn and move on. So your peak, low peak and high peak of the mountain could be as high or low it wants to be. So go ahead and make that, everybody. Horizontal tangents. And I'm going to write on here, we have a horizontal tangent. Make sure they're lined up with f prime is equal to 0. So the behavior going up initially should be the same. And then how peak, high peak doesn't really matter. Is everyone good with this? Yes? Okay.